And okay, 1, 2, 3. So I forget this. I don't bother about that. I will. Okay.
I still cannot see anything. Let me try to reload. Oh, actually, I can see it.
It works now.
Yeah, it works.
Okay.
Yeah,
Great.
picture is here.
So now we can start advertise.
Yeah, sure.
Facebook, GDG Vilnius. I will probably post it to
Yeah,
the.
so Facebook. Actually, yes, and after the streaming, it would be the records.
Here's
the
the live streaming. The live.
Then it would be the link after this. So
streaming of
you could see
GDG Vilnius.
recording after.
James Milner presentation about the WebAssembly. Okay, share now. Could someone let guests come in? And also, welcome everyone to the event. Just a reminder that there behind the glass there is drinks, snacks, so help yourself please. Use it as intended, and also after the James presentation there will be pizzas coming in. It's 7:30 scheduled target time. So please stay network, ask James questions. He came very long distance to present us this topic, which looks that everyone is interested. So it's 6 minutes till the presentation, and now I'm gonna share the live streams link on the meetup and the Facebook page, so please share to your friends who might be interested in the topic but couldn't make it today to do this venue. Okay. Event.
Will recording be available afterwards?
Yes. The intention of this live streaming is to have it offline, just as a backup. We'll try to record on this camera as well, so most probably we will have a recording. Also, just to let everyone know, another side note, behind this wall there are toilets. Just if you will be looking for place. Okay. Seems like we are live. Seems like excellent connection. So if anyone will be interested for Wi-Fi, it's here. It's quite complicated. Let's change the world.
Let's call it secure. It's very secure.
It's secure. We had security presentation last time. Roman knows a lot about it. So, and note the $sign at the end. And by the way, guys, do you know what is the symbol on the keyboard when you click Shift 4? Yeah, so it's check it out at home. It's the last symbol on our Wi-Fi password. So I'm gonna grab some drink myself. So we have 3 minutes. Everyone is coming on this, so Windows here, please. Ja, muszę to James? We will need to set a microphone to you. Last time someone gave us a feedback that we need to get better at marking. Yeah, I think that would even look better on camera. And then
Yeah. That's,
can you hear the
everyone hear me okay?
Yeah,
Cool.
that's great. So, okay, I think I will turn on the recording on this backup camera. Okay, live streaming is excellent. Okay, so welcome everyone to the GDG Vilnius meetup, which we will have James Milner today presenting about WebAssembly. I wanted to make a really short intro about what is GDG. So GDG stands for Google Developer Groups, and it's an international and a movement where local technology community is gathering to share knowledge, to learn something new, to train a skill, to be an international speaker like James, and basically so everyone would know more and be better developers. This event is hosted at Shift for Payments Lithuania, so food and snacks is provided by the company, and after the James presentation, around 7:30, we will have pizzas. So please stay around the network, share some things you would like to present during our next meetup. Speakers are always welcome to our meetups, and I hope to see you next time. I have shared live streaming links on our Facebook and meetup pages, so please share it with those whom you think might be interested in the topic. And the recording should be available on YouTube after the event. So let's give a round of applause to James Milner. Welcome.
Thank you. Yeah, no, it's great to be here. First time in Lithuania, so it's great to also be giving a talk whilst I'm here. So yeah, this is my talk, WebAssembly, Changing the Web Forever. My name is James Milner. I'm a software engineer at a company called SitePen. We're essentially a web app consultancy. They're based out of the States. We mostly build kind of enterprise web applications for kind of big corporates like banks and big hotel chains, that kind of stuff. So a lot of interesting problems that kind of come out of doing that. I'm a Google developer expert for web technologies, and I also blog on a website which is lotsstream.io, and you can find me on Twitter if any of you use Twitter, at James L. Milner. So that's just my name with an L in the middle. That's quite loud.
Use clicker, and I think you can stand closer to the audience.
So before I dig too much into WebAssembly, I kind of want to give a bit of a background about why WebAssembly is important, or why it kind of came about to be how it is today. So I think the core thing to understand here is that people have been trying to write non-JavaScript code in the browser for a very long time. And this has mostly been kind of through the form of like plugins, because the browser only has the JavaScript like runtime environment. So historically, like we had things like ActiveX or Flash, which was available through things like the Netscape plugin API, which hosted things like Java and Silverlight. But they were fine. But they kind of had a bunch of issues in that they weren't particularly very well sandboxed. They kind of led to like security issues. So you often had a lot of security issues with things like Flash and Java especially. And so Google started building this thing called NACI, which is the I can't remember exactly what it stands for. It's basically another platform, a native client. That's what it stands for. And that was like an attempt to kind of fix some of the problems with the Netscape plugin API, to provide a better platform for creating plugins and writing like C and C++ code for the browser. And alongside this, at the similar sorts of timeframes, Mozilla started writing something called ASM.js, or came up with this concept of this thing called ASM.js. And ASM.js was essentially a really strict subset of JavaScript that forced everything into specific types. And because it could do this, it could run faster than just native JavaScript, because JavaScript has to you have to keep recompiling JavaScript to make sure that like your fast paths in your code stay fast, because it's a dynamically typed language. So ASM.js kind of like forced everything into known specific types, which kind of allowed it to run quicker. And kind of these two things were happening at the same time. So it was this kind of this way of allowing people to compile. The goal is essentially to allow people to compile C or C++ or other kind of like languages that we've often used for native development, and bring them onto the web platform. So you could compile a library that's written in, like an image manipulation library that's written in C, compile it to like ASM.js and run it, or in Google Native Client. So where does WebAssembly come into it? So I'm going to give a kind of a bit of a refresher here. So WebAssembly is essentially kind of taking that concept of like the ability to write languages that aren't JavaScript for the browser, but kind of allowing it to happen in a way that's a lot more contained and a lot more integrated into the actual browser itself. So it's particularly inspired a lot by like ASM.js. So that is kind of the entry point, I think, to where WebAssembly kind of came about, because it was kind of moving away from like this plugin model of just having things running in these plugins, and it was kind of insecure, and different browsers were going to implement that differently. So WebAssembly is kind of a kind of standardized way of allowing people to write a bunch of different languages and having them run kind of on the web. So fundamentally, so what is WebAssembly? And this is quite dry, but I'm going to say anyway. So WebAssembly is a binary instruction format for a stack-based virtual machine, which sounds, like I said, it sounds quite dry, but the cool thing about this is because it is so low level, is that you can, and it doesn't make too data, like way of like modeling data, is it allows a whole bunch of different languages to be compiled down to it. Like it's quite permissive in the kind of ways it allows code to be like compiled down to it. Which is really cool because it means that now we have this standardized way of allowing people to write like C or C++ or Rust or Go on. And the other kind of benefit of this approach is that it kind of can allow us to get nearer to kind of native performance as well, because we don't have, well, first of all, like it's a binary format, it's smaller, it's going to transfer over the wire faster. We don't actually have to pass and compile, well, we have to compile it, we don't have to pass it in the same way that we do with JavaScript. We just have to decode it and then we can compile it. So that whole like startup time is significantly or is faster than JavaScript. And you also don't have to keep recompiling those like hot parts in your code, because they just get compiled once, because WebAssembly is like strongly typed. It doesn't need to kind of keep recompiling it to optimize it, like optimizing compiling. So this leads to kind of like fast and more predictable code, because obviously different JavaScript engines will run JavaScript in slightly different ways and compile, like make optimizations in slightly different ways. Whereas WebAssembly gives you a lot more of like a uniform execution time across different runtimes. Yeah, so I talked a little bit about WebAssembly, but I want to talk a little bit more about like those high-level goals. So the first one, which I touched on briefly, was about making it fast. So it's aiming for this kind of near-native performance. It's easy, it's efficient to kind of compile, it's efficient to transfer, and it has very consistent running times. The next thing is it's safe. So code is validated and it executes in a memory-safe way in like a sandbox environment. So that's kind of, it fits quite nicely with the browser in that way, in that like everything is very like sandboxed and like locked down, which kind of is nice because it aims to prevent like data corruption or like leaking like data from memory. And the last thing is that it's portable. So kind of as I touched on this a little bit before, but WebAssembly doesn't try and make too many assumptions about like the architecture that it's running on. So the aim is just that it can like kind of run on almost any kind of CPU architecture, and it doesn't kind of particularly favor any one source programming language. So it aims to just be able to be this kind of thing that can just kind of run on any device anywhere. It's interesting. So one problem with a binary-based format is that it can be quite hard to debug. So it also ships with a text-based format, which you can actually write this text-based format and you could compile the text-based format. Like I wouldn't advise doing it, but it does work. And then, so this is easier to see. Like if you compile a WebAssembly program, you'll get like a .wat or WAST, like depending on the compiler file, and it looks a little something like this. So you can kind of see there that there's a constant that's defined as the number 42, and it exports it out. I'll actually tell you what's going on exactly in this function. So in here, when you define like a WebAssembly program, you define this imports. So WebAssembly program can import, in the browser, for example, can import a JavaScript function. So what we've actually done here, imported a JavaScript function. In this case, it's actually just like a console log. And we take the import function and then we call it with the number 42. So it's just logging out the number 42 essentially. But yeah. And so the other cool thing, like the core premise here, is about being able to take a bunch of languages, like predominantly strictly typed languages, and compile those down to WebAssembly. So the cool thing is that you could write programs in a whole host of a bunch of different languages. So the core ones that people know about, especially in relation to WebAssembly, are languages like Rust or C or C++. But there's also kind of varying degrees and experimental support for a bunch of other different languages. So Go is quite a notable one. Haskell, C# via this project called Blazor, which is from Microsoft. My personal favorite, which is AssemblyScript, which is a TypeScript compiler to WebAssembly, but it's actually like a subset of TypeScript to WebAssembly, which I think is funny because TypeScript is a superset of JavaScript, so it's a subset of a superset. And then Go, which is kind of one that you would kind of predict it to be up there if you see Rust as well. So they're obviously like trying to compete there a little bit, I think. But yeah, there's a whole host of different languages that you can write and then compile down to WebAssembly. So the number one question I always get asked about WebAssembly is, will it replace JavaScript? The simple answer is no, because the things that they're good at and the things that they're designed for or currently capable of doing are kind of very different. So to me, like, WebAssembly is something that sits alongside JavaScript. It's something that you can use to augment your current program or your current application. It's good at like a subset of tasks. I kind of see JavaScript as this kind of generic thing that can just do anything, and WebAssembly is very good at things like number manipulation or just dealing with large arrays of data, for example. It's fantastic at doing that kind of stuff. So the use cases where I think you'll see like WebAssembly and starting to see WebAssembly taking foothold is things like games, anything where you're processing lots of instructions very quickly, like mapping, for example, like especially like 3D mapping, image manipulation. So, for example, running like something like Photoshop or a version of Photoshop like in the browser, or audio, like like a sequencer, or I don't know much about audio, so but some various audio manipulation programs just running kind of in the browser, which I think is really cool. So how do we actually use it? Well, at the moment, the probably easiest ways to get going, like quickly, just to explore, like using WebAssembly would be like in the browser, is obviously a cool place, or also Node.js has support for WebAssembly. So if you're in the browser, you could do something a little bit like this. So as I was mentioning before in the text code that I showed you, you can have an import object that you're going to pass into your program. So in this case, it's just like a console log, and then we're going to do WebAssembly, which is the global WebAssembly object in the browser, and do compile streaming. And you're going to pass that a fetch to your WebAssembly program. And the cool thing about this is that it's going to fetch and be streamingly compiling your program at the same time. So as soon as that data is coming in, it's going to start compiling it, and by the time that it's finished fetching the data, the whole program's going to have been compiled, which is cool. Then once that's done, you can instantiate your WebAssembly program with the imported object. In this case, it's just got that, we're just passing in that console log. And then in this case, we take that instantiation and we just call whatever the exported function is. So in the WASP file, it was just the number 42. So this program would just log out the number 42, for example, which is very basic, but hopefully it kind of gives you an understanding about how you might actually use WebAssembly in the browser today. I was going to do a little demo. Had some technical difficulties, unfortunately. I couldn't use my own laptop. But I was essentially going to show you, like I was saying, I'm a huge fan of AssemblyScript, and I was just going to show you how to write a really quick AssemblyScript program. And the nice thing about that is I could have just done it on this machine, but it would have meant swapping between the displays and stuff. So, but yeah, go check it out. AssemblyScript's fantastic. How many of you know TypeScript? Right. So any of you could go ahead tonight, go home, install npm install AssemblyScript, and then just write a tiny TypeScript program that would compile to WebAssembly, and it would take you 5 minutes. It's really cool. And so another kind of thing you end up hearing is like, oh yeah, but I actually need to support a whole host of different browsers. And the interesting thing is that WebAssembly actually has really fantastic support on all major current browsers. So unless you are doing stuff on Internet Explorer, which I don't know, maybe that has wider support here, but I mean, supposedly globally, WebAssembly has 86% support across like global browsers, which I think is pretty impressive for a web standard. Normally it takes like years to get anything close to that. And the other cool thing is that you can always call back to JavaScript. So a lot of the tools that allow you to compile to WebAssembly also allow you to compile down to JavaScript as well. So you can use mscripten, which will compile to like asm.js or WASM for your C or C++ program, and I think it supports like Rust as well. Or assembly script can also compile to JavaScript as well. So you could write the same program and then just have it export to JavaScript or WebAssembly, and then you could just do some feature detection, just say like, does this browser support WebAssembly? And if it does, get the WebAssembly version, and if not, then you just get the JavaScript version. So the other thing is that you hear a lot is that nobody's actually using WebAssembly. And I'll be honest, it probably hasn't caught on as quickly as, like I still think it's kind of maturing and getting there as a technology, but there's still some really interesting use cases out there for WebAssembly, in my opinion. So a really great example is Figma. Who's familiar with Figma? It's like a web-based design tool. So if you were a designer, you can like use it like SketchUp or one of those like design tools. And the interesting thing here is that they've been using WebAssembly to basically like load in the documents that they use, like the actual design documents. And moving over to the WebAssembly engine increased the load time by like 3 times, regardless of the size of the document. So just like a linear 300% improvement, which I thought was pretty cool. Another example is Unity. So Unity switched from using asm.js over to WebAssembly for their like WebGL target by default, and that decreased like the amount of the actual code that they were shipping, so the bundle size, improved performance slightly, and it also allowed them to change the amount of memory that they could allocate like at runtime as well, which is something they couldn't do before. Here's another example which I think is really interesting, which is a company called AutoCAD, which is like a CAD company. And they essentially took like a 35-year-old code base, which I don't even want to dream about like is inside there. And they compiled that from C++ or C to the web using WebAssembly. And now you can just run it in your browser, which I think is like incredible, because the amount of time and energy it would take to rewrite that entire program to JavaScript or TypeScript or whatever is like phenomenal, like years and years of work, right?
So they changed just compiler and that's it?
Yes, sorry, I'm going crazy with the clicker. No, you just threw me and I was like, ah. Yes, they essentially, no, they set, you can set they probably, I think they probably had to do a little bit of work to like glue it up to the UI and stuff, but the core program is just written in C, and then they just compile that to WebAssembly.
So how do you compile things into WebAssembly? Is it a converter or compiler plugin, or?
I mean, it depends like on the source language, but
let's say C, C++.
Yeah, so you would use something like mscripten, which is just like a, I'm not like a C, C++ expert, but yeah, you can use mscripten to compile to WebAssembly and JavaScript, for example. So it's just like tools that you can use. I think it's based on like LLVM, which is like a thing for compiling from various languages to other languages. Another example is Squoosh app. So has anyone heard of Squoosh? There's like an app that was built by the Chrome Labs team, and it's essentially image compression app for the web, and it's all and it uses a bunch of libraries that were written in C++ for image compression and compiles those to WebAssembly. So you can just drag and drop images into the browser and it will compress them. Wrong way. And my last example is eBay. And I thought this was quite a cool little use case, was when you're like putting up a listing on eBay on the native app, you can hold up the camera, hold up the barcode of whatever it is that you're trying to sell, and it will auto-complete that for you. But the problem is on the web that there isn't like a native barcode scanner. So what they did was that they took a barcode scanner library that was written in, I think, C++, and then they compiled that to WebAssembly, and then they were able to use that like in their web application, and that kind of gave them that feature parity or like comparable like feature to their mobile application, which I think is pretty cool. Rather than again writing a new barcode scanning library in JavaScript from scratch and spending weeks, months, years writing that.
I think we wrote in JavaScript, but then tried to use WebAssembly, and the improvement was 25. Because at first it was 2 frames per second, we could scan on 2 frames, and then it improved, I don't know, 30 frames per second, something like that.
So like what they ended up doing in the end is having the JavaScript library running in one thread, the WebAssembly. So they had a bunch of different libraries that they were using, because none of them worked 100% effectively. So they just ran all 3 in web workers, and then they just raced them to see which one can find an answer, which I thought was pretty funny, because it's just like, yeah, like none of them were 100% perfect. So they were just like, all right, well, we'll just all of you try it, and whoever is successful, like, we'll just take that. But yeah, you're right. Yeah, they didn't completely remove the JavaScript library. They were running it in concurrently at the same time. But yeah, I still think it was interesting because that they were able to add like that library in from C rather than trying to rewrite the JavaScript library or doing anything from scratch, which I think is nice. Sorry. So, and this kind of touches on nicely what we were just talking about, like running like threads, is where does WebAssembly actually run, like when you run it? And the answer is that it just runs on the main thread, like wherever your JavaScript is running. So obviously a lot of things that you might use WebAssembly for are pretty processing intensive, right? They take a long time to do. And when you do that, you're going to block the main thread, your FPS is going to drop quite dramatically, you're going to be blocking user interactions, the whole app's just going to like freeze. So what you can actually do is just run it in a web worker, which is pretty nice because it essentially allows you to do the same work, but you're running it off the main thread, and the user can keep doing whatever it is that they were doing, keep interacting with the page, and that work will just be off running in a separate thread. And there's a really nice library for doing this called WASM worker. And so essentially you can just pass it your WASM file, it will compile that like off the main thread, and then you can just pass it arguments, and it will transfer those over to that separate thread, and then return you the answer, which is nice. It looks a little something like this. So you can just import WASM worker from the module, and then you give it the file that you want to use. So here we've got like a real basic WASM program that just adds numbers together, right? So once that's returned, you can use the exported functions to just add, and then that will return whatever the number that was added. So you can kind of just use it like you don't have to think about, like normally with a web worker you have to have the web worker logic like in a separate file or wherever it might be, but this just uses like inline workers, so under the hood it's just creating, doing all that for you, so you don't have to worry about managing separate files or doing any, it just encapsulates and abstracts all that away from you, which is really nice. Right, so this is where it gets interesting, is what about frameworks, and will React be using WebAssembly next week, and all these kinds of things. So the answer is not yet. So as it stands, WebAssembly only really understands numbers, which, as you can imagine, if you're a framework, isn't particularly useful, because it can't understand really even things like strings, for example. It can only understand integers and floating point numbers at the moment. And so, for example, if you even if you wanted to pass a string to WebAssembly, you have to transform that into like the Unicode representation of that, pass that to WebAssembly, and then when you get the string back on the other side, you have to undo all that to turn it back into a string. So you're always like having to translate to numbers, and then from numbers to a string on the JavaScript side. So it's always like, it's a bit problematic, especially, for example, like WebAssembly has no concept of like what a DOM node is, for example, like like a div or a span or whatever it might be. But there is a current proposal that's currently being implemented called reference types. So this is kind of like the first step towards kind of maybe potentially integrating with frameworks. And what reference types essentially allow you to do is you can reference something in the JavaScript like heap, for example, like a DOM node, and you can pass it through to WebAssembly. WebAssembly can't do anything with it, but you can pass it through back to the other side. So, for example, you can pass through DOM nodes, you can pass through strings, all these kinds of things, and WebAssembly can't do anything with them, but it can pass them through without having to do any kind of like translation. For example, when I was talking about the strings, it wouldn't have to transform that down to numbers, it can just pass it through. Which is, in and of itself, is not super useful yet, but it's the first step towards integrating with the DOM, because at least it can pass it through, right? So you could pass DOM nodes to WebAssembly, and then it could pass it to another JavaScript function that does something with it. So the next thing you kind of need to do after that is, like, now that you can pass through these DOM nodes, is WebAssembly needs to have some ability to know, like, for example, when that's been garbage collected in the say, for example, it's been like deleted from the page and deleted from your JavaScript heap. WebAssembly needs to be able to know that that's happened. So if something gets removed from the DOM, WebAssembly can know about it. Yes, the next kind of step there is integrating with the JavaScript garbage collection. Sorry, I'm just going to get some more. And so, kind of, well, not the last thing, but another thing that kind of needs to happen here to integrate with the frameworks is actual integrations with the web APIs themselves. So there's a thing called WebIDL, which is Web Interface Definition Language, and this is essentially like how a language like knows how to talk to the browser and pass like the correct types to the browser. So, for example, like it will know like if you're calling like create element or whatever, it knows that when it knows that it takes a string, for example, to create a div if you're creating a div. And these bindings of like of the host language to the like browser language, like you need to do some translation there, and it needs to understand that translation. So essentially, WebAssembly needs to be able to take its types and map those onto the WebIDL types, so that the browser can understand what it's trying to say, and it can interact with those web APIs directly, rather than having to proxy like through JavaScript, which is what has to happen at the moment. So you can like directly call web APIs like from WebAssembly. So will all of this change the web forever? So for me, I think the answer is yes, but maybe not like I don't think it's going to be like some big revolution where I think like it's kind of going to just be business as usual, but we're going to be able to do some new and cooler things, which I think is cool. I think like the three kind of main ways that I see it kind of transforming things is that we can take libraries that are written in a bunch of different other languages and then just compile those to the web. So we don't have to rewrite like like image compression libraries in JavaScript. Like we can just take the ones that are written in C or C++ and then just compile them down. The next thing is being able to write like performant and consistently performant code for like real data intensive applications, which I think is really useful for things that have often been kind of bound towards like desktop applications. So things like image manipulation or audio manipulation, anything where there's lots of data that needs to be manipulated.
I have a question in this place. So do you think like reporting could be could use this? Because I think reporting is still better to do at the back end. It's performant code which requires like a quick responses, while like you said, image manipulation, audio editing, gaming, right? But like for performance intensive report generation, it's not a thing.
I think rendering reports make sense.
Yeah, but I think would you do like report rendering, like statistics, total amount?
Yeah, I don't know too much about like
reporting,
generating reports. Yeah, but anything that's like numerically intensive, like definitely, like WebAssembly is fantastic. If you want like a really fast calculator, like WebAssembly is awesome at that. So yeah, anything with like statistics or number crunching is probably like quite a good use case. Yeah.
Okay.
I know, for example, like there's a company out there that does. It can convert. It's all about like converting stuff to like PDFs, stuff like that. So if you're trying to do that kind of thing, then it's probably not a bad use case. Yeah, and then the last thing I've got there is enabling apps that have often been bound to native environments. So, for example, I was talking about those like AutoCAD, which has for years has been a desktop application. But you could think of things like Photoshop or anything like of that kind of nature, where you're dealing with big quantities of data. Sorry, that should be there. I don't know why that slide's in there so twice. So I think like the JavaScript ecosystem has developed like quite substantially. Like we have a whole host of things that have kind of come out of JavaScript. Like JavaScript has become this kind of big, like it's just become this monster, right? Like it's just, you can do anything and everything is written in JavaScript nowadays. Everything from like back-end development in Node.js. You can build mobile applications with Ionic or React Native, desktop apps with Electron. Do IoT stuff with, I think it's called Johnny 5. I've not used it, but it's for doing like IoT applications. I think I'll just be like really interested to see where this goes, like with WebAssembly and like what comes out of it as a technology, like what that will thrive and allow to grow. So a good example might be, so now, for example, in Node, a lot of those native modules that you like, if you ever do npm install and it starts like compiling some native module for your system, WebAssembly would be a great use case there, because you could just ship the WebAssembly binary and you just know that it's going to run on whatever machine is on that computer. Like you won't have to compile it for Mac or compile it for Linux or compile it for Windows. Like you just ship the WebAssembly binary and it's just like problem solved. So I think that's really cool. Kind of seeing some adoption on like what's like serverless and edge computing, like just being able to because of the startup times for like WebAssembly programs are very short. It's quite ideal for like like edge computing and serverless computing. So for example, Cloudflare allows you to run WebAssembly on the edge, and I think Fastly, which is like another like edge computing company, is working towards using like WebAssembly for their like edge computing like platform. Yeah, so there's this was quite an interesting quote. So Solomon Hykes is the co-founder of Docker, and he kind of sees it as if if WebAssembly had been around like when they had invented, like were looking to invent Docker, they might not have needed to invent Docker, which I think is actually quite a massive claim considering that he founded Docker. But the interesting thing here is that once you start getting integration with the actual environments that like WebAssembly is running in, so you can do things like opening files or interfacing with the network, like what's going to be possible with WebAssembly is going to be like absolutely enormous, and you're going to be able to like in theory be able to run those programs on a whole bunch of different ecosystems, different environments. Sorry. Yeah, that's all I have, which is good because I've just completely lost my voice. So thanks a lot.
Before anyone will ask questions from the audience here, I have a question from the live stream watcher. Vykintas Kumškis was asking, what is the biggest project you have done with WebAssemblies? If it is available, would be great to see it and inspect file sizes, load times, etc.
Biggest one in terms of
maybe your own personal and maybe some other big ones.
I'm just thinking about in terms of the biggest that is like open source.
I suppose like running live.
Yeah. Okay. Well, a good example for that would be the Squoosh app, which is the image compression library application that's built by the people at Chrome, because that's all open source. Like you can go and inspect all the WASM files and source files in there.
Squoosh,
like it's S-Q-U-I. No, U-O-O-S-H, I think.
Squoosh.
I think it's just Squoosh.
Oh, Squoosh app. Yeah. Oh yeah.
And that's a really nice example because you can just go and inspect the source code. It's just on GitHub. In terms of, I did so there's a library called Pixel Match, which is essentially for doing diffing images, and that's used a lot for in, for example, testing suites where you want to do like diff2 screenshots. So if you have, like a button's moved or like a button's changed color or like the app is like changed in some way, and it will like fail the test if the difference is too big. And essentially I rewrote that in a assembly script, and that's on my GitHub, and it's just called Pixel Match dash ASC, so ASC is assembly script. But it's quite nice because you can compare the difference between the JavaScript implementation and the assembly script implementation. And I think they're pretty comparable in, I think that the WebAssembly version is slightly faster for like smaller images, and then the JavaScript version is slightly faster for bigger images. So yeah, it's an interesting point because the WebAssembly isn't, people get confused, like, and it threw me a little bit, is that WebAssembly isn't always like inherently faster because like V8 and all the JavaScript engines are so insanely well optimized that it's kind of like performance difference isn't always as big, and especially if you're using a lot of like non-numeric types in your program, because it has to do like all the conversion. But yeah, if anyone else wants to ask any questions, I'm happy to.
Yeah, so my question is regarding assembly script and memory management.
Yeah.
how do you do memory management? Yeah, because like, for example, I know that right now WebAssembly doesn't support like garbage collection.
Yeah, I mean, it doesn't. Yeah, so WebAssembly has like just linear block memory, and you have to do like deallocation of memory yourself. So I think I'm not 100% sure like exactly how assembly script does it, but like I'd have to look at like how they're doing it. But
so from developer perspective, you don't like do manual management. Does it for you?
In assembly script, like in your assembly program, like when you would have to like deallocate that memory yourself manually. No, but it's like you can just call like deallocate of whatever the memory that you've referenced is, and it will like deallocate that memory. So yeah, you do have to do it yourself. You're right, like WebAssembly doesn't have garbage collection, so.
How did you learn WebAssembly? Can you recommend any good study material?
I would recommend, yes, actually. There's a website called WebAssembly by example.dev by a guy called Aaron Turner. And that has examples of how to get started with Rust and also how to get started with assembly script. But again, I'm a bit biased because I'm a fan of assembly script, but if you just go on their doc site, it's actually genuinely like got a really nice introduction. So I think like you could go home today and just go on the assembly script site and you could get something running in like 5-10 minutes.
Do you use WebAssemblies in your company?
Yeah, no.
Can you please repeat the question for the recording?
Yeah, sure. So the question was, do we use WebAssembly for our the company that we work at? And the answer to that is no, we haven't used it on anything that long. I've only been there a year, so I haven't had a chance to like make everyone like start using it yet. But no, and it's a fair point. And I think there are really specific, like I said, the use cases are quite specific. So they are things around like if you're building more of something that would generally be more of like a native application, like that you're doing like a lot of like processing of data, then it's always like a good use case. Anything with kind of audio, imagery, video. It's used quite a lot in like a lot of like blockchain applications, which I found really interesting. I don't know a lot about blockchain, but it seems to have really taken off in blockchain for some reason.
So do you think we might find soon some great performing Bitcoin miners in our machines running while we watch?
I mean, you're joking, but like they
are run in WebAssembly.
Sorry?
Smart contracts are run in WebAssembly, and they are starting to implement this feature. So basically, they are willing to use WebAssembly as an engine to run smart contracts.
I think, yeah, because it's like one of its main aims is around sandboxing and like being secure and correctness and stuff like that. So I think maybe that's why, I don't know, maybe that's why it's become real popular. But the mining stuff is really interesting because, so you know, you get a lot of these kind of like websites that will have you like behind, like without you knowing, running like these JavaScript Bitcoin miners, or like coin miners or whatever. So a lot of them started shipping WebAssembly versions of that code, which is like really annoying because it's like now everyone's like, the main use case of WebAssembly is to mine bitcoins off other people's machines. Which is just like, no.
Anyone else has a question?
I don't know if it's a question or some statement, but
yes.
I think maybe like TensorFlow for JavaScript.
Yeah, definitely.
It should really improve performance. Oh,
yeah.
Maybe, as I said before.
Yeah, I don't know. I haven't seen. It's really interesting. I haven't seen much in the kind of like machine learning side of things. But like you said, that would make sense. Like it would probably be a really good use case for that.
probably have to like go away and do some research and see like if anyone's doing anything like that at the moment, because if not, it's probably like a real interesting like avenue for doing that.
So right now it feels like WebAssembly is a green field for anyone to start their pet project libraries for everyone to use, and then that could be get very popular.
Yeah, I mean, there's definitely a lot of like, there's definitely a lot of hype around it. Like I think people are quite excited about using it. I think the thing that people like that's not that people stumble on is that you, for example, in like for example web applications, like you can't update the screen or do anything like that. So I guess I would say like if you've got something that's like a very like that is just for example like the image diffing thing that I was talking about, anything of like that kind of nature where you're not like updating the screen or doing anything like that is like a good use case for like a pet project or to use WebAssembly.
Okay,
cool.
Seems like no one else has any questions.
Yeah, I'll be like around for a little bit, so if you just want to come talk, then that's fine.
So thanks, James, and
Thanks
let's everyone go there for some pizzas and see you during next meetup. I'll leave live stream for those who are at home to see that they are missing the networking part. Okay. Pavelai, būsi, neišbėgsi. Darom, pavalgom picos. Čia, man atrodo, galima susiaurinti šitos vietos.
Is it open source? The virtual machine for WebAssembly?
Yeah, I mean, so like there's a bunch of different runtimes for like WebAssembly, and most of them
for different browsers?
They're not for like different browsers. Like so, the browsers will have their own like embedded runtime for WebAssembly, and I'm not sure. I would assume that that's open source, or like alongside like the V8 engine, something like for Chrome and stuff. I don't know. But there's one. There's a few different ones. There's like one called WasmTime, which is from Mozilla. There's one called Lucid, which is from Fastly, who are another like CDN edge cloud computing company. So there's a few different runtimes for WebAssembly itself, but because it's all like an open specification.
So Google just released specifications on it?
Yeah, it's not just Google, it's mostly actually driven by Mozilla.
Oh, okay.
Yeah, they're like the real driving force behind it at the moment. They, like Google are like on board and they're all like for it, but Mozilla are doing a lot of it. Like, there's a woman called like Lynn Clark who's doing all of the work around like integrating WASM with like different operating systems and like environments. So like if you want to access a file or you want to access the network, like doing the specifications around that.
And it makes sense to port it not just to web, but let's say desktop or mobile, and just use it as a Java.
It's similar kind of principles. So what you just said is exactly what I was saying about like Lynn Clark, like they're working on something called like WASI, which is the WebAssembly systems interface, and that's all about like it's kind of like POSIX but for everything. So like it's like a specification about like how WebAssembly interfaces with like accessing files or like accessing a network, or like, and regardless of the environment, as long as it adheres to that specification, then it will
should just like run. That's like where it's at. So like eventually you get to that point, but it's all still just kind of being standardized and stuff. Yeah, it's all like all the it's all on GitHub. Like the entire standards process is all like you can just go and if you want to see like where they're at with everything, it's all like public. Some of it's a bit like it's quite hard to follow because it's like unless you've been like following the whole thing, and like some of the readmes could be a bit clearer or like give a bit more like background. But I think that's just like any project ever. Yeah, I think it's exciting. It's like I don't know. I'm in two minds about it because I'm like I think it's really exciting, but then it's also like I guess I haven't seen it get as much adoption yet as like maybe I would have hoped. So but I can't play.
Well, you mentioned Unity as an example, so guys like that, they're always looking at the technology, you know, they're migrated from it.
It's been really popular with people that have like existing technology that they want to port like to the web. So like Unity is like a great example, because obviously like they have like all of the Unity stuff's written in I don't know, C, C++, C#, I don't know, not JavaScript, right? So, any company that has like big legacy libraries that they don't like rewrite, it's like Unity, Unreal, to use it.
I mean, for desktop apps, things like Chromebooks, they're getting quite popular, but nobody wants to develop an app for Chromebook, you know, so just port it to them.
Yeah, that's kind of what I see is like it's happening already, like gradually. Just because like and you can just do more and more with the web now as well. Like the number of APIs and stuff is just like I can't keep up with it. Every week, like Chrome seems to be like something new that I hadn't even heard of before. Yeah, it's a cool time to be like building apps.
I got an impression that maybe it's not for every language, because it's like I, for example, have a code written in C where I deallocate memory manually, probably will work fine, but if I will run the Kotlin code or Java, so garbage collectors, how we handle this cases?
Well, I think it's like really, I think it's like with, for example, JavaScript is like or TypeScript. It's like it depends what you're doing inside the code itself will determine about whether it can be compiled. It's like, for example, if you're writing Kotlin code that references like Android APIs, then it's obviously not going to work. Right? But if you just have like a prime number generator written in Kotlin, then it should just be it's fine. It just depends how much it's like interfacing with like system APIs or stuff like that. And what you're saying about like like Java, for example, is like I think the goal is that like so they won't implement a garbage collector in WebAssembly. Like they will just allow WebAssembly to like borrow the garbage collection of like whichever environment is like available. So like with JavaScript, you just use the JavaScript garbage collector. Or because like the problem is like you would never be able to write a garbage collector for WebAssembly that would be that would work with every single source language. So it's easier just to like borrow the garbage collector from the host language. Yeah. I hope that kind of
because at the moment I think it doesn't make much sense to run the Java code maybe for the WebAssembly.
No, I'm not sure if you can, like, Kotlin's the only language I know, because that's a JVM language, right? That you can compile to something. I'm not sure about Java or Clojure or Scala or anything. JavaScript. I'm sure that they can just figure out a way to
I was actually kind of concerned about WebAssembly code, especially WebAssembly and client machine. And all those mathematical computations that are of course, be free of a lot of tasks. But it's actually keeping my mind all planning down these long things. When something is are essential and you basically get that burden the machine runs out.
I think like it's that's always like a trade-off, like with building like client server applications. It's like how much work should be on the client, how much work should be on the server. Yeah, I think it's like that's true. But it's like if you were running the same app in JavaScript, like you'd have having the same problem, right? And it's interesting like how much memory and
it's actually this question is not bound to
well, I guess my point would be like hopefully like if WebAssembly is faster, then you're doing less work than you'd be doing like in JavaScript. But I guess your point's interesting in that like maybe people will get a bit like generous with how much like stuff that they expect the client to do. I think it's
you put a rock on the Chrome or something.
Right.
You get all of that data.
Well, it's confused. I think like well, did you see like somebody compiled like Windows 2000 for the web and it just gets like ridiculous. That's the thing that you allow to happen.
So currently you're like between WebAssembly and
yeah, like on that boundary. So like if you, for example, pass a string, like you would encode that to like Unicode or like UTF-8 or UTF-16 or whichever. Yeah, like a numeric representation. And then if you want to do stuff with those strings, you're just operating on the Unicode values, which is a bit, it works, but it's a bit like, it's not very like a great developer experience. It does work, like, I guess. It's not a huge problem. So yeah, but things like DOM nodes or like JavaScript objects and stuff like that, that's where it gets real messy because it's like even something like encoding JSON into like linear memory and like operating on that in linear memory. It's like it just wasn't designed to like be operated on in that way. So yeah, like it's possible, but it's just messy. Like it's not like it's not as straightforward as it is to operate on. Like like in JavaScript, you can just do whatever you want at any time.
There's still more about GDG. How do you participate in there? And
yeah, you mean like GDG or GDE?
GDG, like Google developers.
Yeah. So I'm not like super. So this GDG is like all across the world, and they're just all run by volunteers. I think like Google does obviously give them like some support like financially and like they have like summits for like organisers and stuff like that. But normally it's just like a case of just getting in touch with like organisers and like depends like how you want to get involved. Like if you want to speak, or if you want to like help with it, or like yeah, it's just a case of like just getting in touch with the people who organise it.
So it's not like organization, not like a separate.
Yeah, it's not like it's all like community run, which I find I think this is just me personally. I'd like to see like maybe Google do more like like send more people there or like, be more involved. But yeah, it's an interesting one. Like it's an interesting.
Is it how you find this? Like they invited you for the G?
Well, so like they're trying to encourage like the Google like developer experts to be like more to go to like more of the GDG events. So they're like putting more and more of the developer experts in touch with like GDGs so that they can like organize to speak or like organize like an event. I mean, the big push at the moment is around like have you heard of like the DevFest? So like every year, generally like every year, the GDG group will run like a DevFest, and they happen like all over the world. And they're essentially like it's essentially like a meetup, but it will last like the whole day, and they'll have like maybe like different tracks, so like one for like Android, one for web, one for cloud, one for whatever it might be. Yeah, but that's like the big thing at the moment. So there's like there might be one here somewhere. I haven't looked into it. There's definitely ones in like there's one in London and like next month. But most major cities will have one. I'll be honest, they don't do like a real good job of like advertising them. Like they could do a better job of like promoting it. But,
yeah. That's the first time I heard about it.
Yeah. It's more like people who are like real excited about like good stuff. You know,
You came here, I guess.
From London. Yeah.
So you're traveling around Europe and giving presentations, or is it just
sometimes? Yeah, it's slightly random. Like it's not like I was in Georgia and Tbilisi for DevFest over there. Just been in like Ukraine for JavaScript conference in Kharkiv, which is like in Ukraine. That's about it. Like the main gets pretty but it's cool. It's like a really nice way to like see the cities and stuff and just like, get a feel for a place.
You came here today?
I flew in yesterday.
You were seeing
yeah, we walked. Well, we went. You know, my girlfriend. We went to like the Illusions Museum.
Oh right.
It was like pretty big, and like we went to a couple of art museums, just like walked around like the old town. It's really nice.
Like museums, have you been to the mall?
Oh, is that another?
Yeah,
the step.
White one.
Yeah. Well, we saw it. It's really close to where Airbnb is. But we haven't been in. Is it good?
Yeah, that's a good one. And now they have a new exhibition about 90s Lithuania.
Oh yeah.
If you want to hear more about Lithuania and what happened in the wild 90s, that's a very interesting exhibition actually.
Okay.
Even for Lithuanians, it's very
yeah, no, I'll check it out. Is there anything else you guys recommend to see whilst I'm
You know, when you live here, it's not so. It's not so impressive. But
if you like clubbing, bars, or like museums,
pretty open, you know, like coffee bars, museums. Yeah, there's so many bars.
But it's not so big actually. You can just take a second.
It's so nice. Like, I love that like there's so many like nice bars and restaurants like all just like on that just like road. There's a couple of roads and they're just all kind of yeah, no worries. Thanks man.
a cool thing to do would be go to the TV tower. There's a restaurant there which is Milner.
Oh yeah?
Yeah, so
Have you been?
yeah, I've been there like many years ago.
Okay. Cool, I'll check that's a good I'll check it out.
Well,
Yeah, thanks man. Thanks for coming, appreciate it. You read that the eBay article as well.
Time ago.
Yeah, it's really good article. I just simplified it a little bit because I was like, I don't want to tell the full thing. Yeah, because they did a lot of crazy stuff. Like they were like, they run like three for like algorithms in parallel at the same time. Yeah, I thought it was a cool story. I think you're right. I don't know if it's like it's like maybe they don't like how much they were using it was just kind of like one of the first articles I'd seen like where people were talking about using it. So it was just like
my boss is into WebAssembly, so we talked during lunch, so I just googled that article also. But there is some where to improve.
Yeah, massively. It's like, I think it's just taken a long time because they want to make sure they get it right. Like I think like, for example, like JavaScript is like, maybe they made a lot of design choices, like, Brendan Knight made it in like 12 days or whatever, and it's just like, and then everyone has to support that for like the rest of the time. I think they're just being quite careful about making sure they
Want that standard, like standard.
I think it'll take time. I don't know. I think like give it a few years and we'll see what happens. I mean, there are some interesting projects. Yeah, I'd like to see more like high-profile use cases of like the companies using it to do stuff. Like Google. Where do you guys work? Oh, the GS, or like
JavaScript framework for doing the designs and everything. So, I was thinking maybe WebAssembly could improve the performance.
You saw the AutoCAD stuff.
Yeah.
No, there's seems like quite a good use case for I'd be intrigued because it's like I'd be intrigued to know like which language you would like if you were to write it and which language you'd write from. Seems like Rust seems to be really popular and I haven't had the time to sit down and play it. It seems pretty like I think it's quite it's like once you get good at it, it's production harder to pick up than yeah, so I've been using a lot of assembly script, which is TypeScript. It's TypeScript language, but it's like a subset of TypeScript, so you can't use like interfaces. There's a few other little, some of the classes don't work. Just various parts of it are like not quite there, but they're getting there. It's just like again, it's just things take time to get to a point where you can use them. But I just like it because you can give it to somebody. Like even if you just knew like JavaScript, you could probably figure it out. It's not the learning curve is quite shallow. So it's quite an easy way to get people using WebAssembly. Using WebAssembly quickly, just because it's like you don't have to somebody doesn't have to learn Rust or C++ or So Bentley is in. They have an office in they have an office in the UK somewhere as well.
Yeah.
But it's not in London. It's like outside London.
I'm not really sure.
Okay.
You can basically work remote from anywhere you want.
For the side.
I used to work for a company called Esri. They're more like less CAD and more GIS. Like mapping systems rather than like building things.
So
Yeah,
basically you are retired.
I have friends who worked at Bentley for a while. It wasn't anything exciting, it was just, I can just show you now. I was just going to show.
So how do you like the online
like you can go
like Udemy,
it's just an assembly script demo, so you can just install assembly script and then put it in it. And I just had an example where you can just do so like when you scaffold like a new product, you get like a bunch of lines, so like just build like your project, and I can show you like so it just gives you like a source file and you can write this is assembly script, so it's not TypeScript. So you just have an add function that takes the 32 bits or 232 bits and essentially I was going to show like this is the node script that essentially takes the like that's a file that gets compiled, turns it to a TypeScript essentially TypeScript, and then with that you can add numbers together. And I was just going to show like for example if I run this script prints like 4 so like that's 2, but like if I could change this to like
I just thought like the problem is the curriculum. Then I thought like all the online universities are
no, because that's just like a pure function, so it doesn't have there's no you can
workshop
I mean you can have like in WebAssembly in general like it is stateful, so you could because it's just like that linear memory, like you can store whatever you want in there, right? You can store it will stay there until you like to allocate it, so like this function will probably what it will do is like add the numbers, return the numbers, and then just deallocate the numbers. But you could like there are ways of writing it. You could write to keep the state. But if I do build, this is just going to build the new WebAssembly file. If I do return, it's like a really basic example, but it just shows that like you could write an assembly script program and then you can basically write whatever you want. I think we'll show you more in-depth examples.
Thanks for the presentation.
Yeah, no worries, man. Thanks for coming. I appreciate it. This is what I was saying, the pixel patch. To show you it's a bit more like in-depth. Yeah, it's just like a little nothing serious. So like one of the annoying things about WebAssembly script is the functions you can't pass objects. So you have to pass each argument so like like normally in JavaScript you would just pass like an option like objects. Whereas in this, you have to pass in everything, like ding, 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 like even if it's empty, you have to pass in like null or whatever, which is a bit painful. But essentially, like yeah, it just goes through a bunch of things to work out like a page. But I just wanted to show you like a bit more of it, like you know, like you could do something more substantial. And you can like full function within functions, like do anything you'd normally do in JavaScript or TypeScript or whatever. I just want to show you guys that. Yeah, because it's like TypeScript, it just like it just has whatever TypeScript has, which is it's kind of like Italian. It's basically TypeScript.
Bet aš evento metu postinau pavyko paleisti tiesiog ryte prikreipiau kamerą, turėjau nusipirkęs šitam Raspberry
And then promoted WebAssembly and knows how to write JavaScript runtime.
Okay, that's good. Who do you remember his name? Yeah, no, check it out. I think it'd be cool to think yeah, I think I might have read a blog post about that. Colin. Yeah. No, Jay, I always have that such
Bet šiaip tai, kaip supratau, tai visai reikalavo CPU nemažai, nes kažkas pradėjo rašyti, tipo prastai girdimas, kažkas rašo, aš girdžiu šaukimą geriau nei šitą mikrofoną. Tada dinktelė mintis, kad nu jo, ne tą mikrofoną pasukata nors. Tai taip aš pakeičiau, kad naudotų kameros mikrofoną. Ir sakė, jau mikrofonas geresnis. Aišku, nėra geras.
I guess it's quite simple. Is that me here?
Pirmą kartą esu live streaminęs Twitch'e su OBS-u, kaip aš ten nežaidžiau, aš žaidžiau 3D modeliavimą.
Thanks.
Tokie biški žaidimai.
Is there a big developer? Yeah.
The same.
Jo, aš irgi Vilnius prisimenu, kai buvo vienas kolega, kuriam
Kind of it's like a good thing. With JavaScript, there's like 4 JavaScript classes. And then there's like, you know, there's show anchor. That is like 2 reactive verbs. You know what I mean? It's just like
gal Facebook'o biški algoritmai pakištų daugiau
I'm not holding you from
No, like I'm just like my girlfriend's coming. I think we're going to try and maybe somewhere to eat like around here. I don't know if there's much around here, but this is kind of like more of a like business park. Business area. Oh yeah? Yeah, no worries. Thanks a lot. Yeah, thanks, man.
So, where are you from?
I live in London. Yeah, and I'm from just south north. I grew up in a town called Bath.
150 kilometers.
Yeah, thanks a lot, man. Take care. Yeah, cool.
So, travel to just for this presentation?
Yeah, I'm like
visit
a bit of a holiday. Yeah. I wanted to come for a while. I went to Riga with my girlfriend, and that was nice. So I thought I'd check out Lithuania as well.
Cool. So, yeah, I think if you have to compare two cities, I would compare Vilnius to Riga.
Yeah, similar kind of vibe. I think the city, like the old town, is quite has quite a European feel to it, like an old European feel to it. I think. Yeah.
You can ride on an hour to get more there.
Yeah, sure.
Even though you are staying here only for 2 years.
Yeah, thanks a lot. I hope that was interesting.
Yeah, it was good.
Cool.
Yeah.
Sorry, this is my French too.
I'll enter my main study of GDG.
Yeah, go for it. Yeah, this has been super cool. It's do you use WhatsApp?
Yeah.
Yeah, cool. It's nice. It's really interesting, like meeting developers from like all over the world. So like different perspectives and different ways of I know people have different ideas about like development and stuff like that.
Absolutely. So at the moment I get to work a lot with Americans.
Oh yeah.
Like
different personalities.
Yeah, I've worked at Barclays a couple of years ago, and Barclays also they have this culture, like corporate culture, that they consider developers in other countries like sort of like outsourced people.
Right. Yeah.
So it's like, but like British are super polite, right? So even though they have this vibe that they are sort of make the decisions, but it's presented in a rather pleasant way. But for the Americans, it's without this sugar on top. It's like, and everyone's like, you know, every dev can go at any moment with the other company. We get offers all the time. It's like, who the fuck do you think you are? Who are you?
That's great. Like, and I think like in America, it's just like, well, like they don't have like here. I mean, sorry, in the UK, if they want to let you go, like they have to give you like a month's notice, and like and in the US, it's just like.
Yeah, could be that. That's why there's a lot of sucking up, you know.
I think but also like weirdly, I find like in this, because the company I work for is American, and I find like a lot of them are like it's like almost. Like sometimes they won't say exactly like what they like. They kind of hide stuff, and like they'll say they won't actually say like exactly what they think. You know what I mean? Like I don't know. It's weird.
To me, there's no worse than that in British.
Yeah, true. Yeah, that's probably true, but in like a different way. I hope the presentation was okay. It's like
did you mean like being double-faced?
Sometimes I feel like that with Americans, like or it's like they're really nice to your face, but then they'll like completely fuck you over in like some other way or something like that. I don't know if you've ever experienced that.
Well, no, the person I dislike the most is quite unpleasant to my face as well.
Well, yeah.
The guy who's like architect and haven't pushed any code ever into our project, so it's like. Well, as I said, I joined quite recently, so I said, okay, we had really cool culture in the previous company where like a lot of the technical decisions were left up to the developers, especially our developers. It's like, okay, let's fucking do the same here, and it's like, no, we're not doing that. Like, what? You have a say in how we work.
Yeah, it's weird. I think it's like always best just to let developers kind of like do what it is they need to do. You know? Like I think it's weird when you start micromanaging developers. It's just like it doesn't seem like a very productive.
Especially good developers, and usually it will like the potential pitfall there is that there are technologies that are hyped up at certain times, and they are not like time tested. And the developers that are following like the trends, let's try this, and sometimes it's not work. But if you have good developers in the team, especially senior ones, they will see that okay, it's not worth the effort. And like potential bugs we're going to have if we migrate to this new technology, it's like it's just out of beta.
Can't win.
Yeah, but usually if I'm usually I'm for leaving it up to the devs, and the mistakes they are going to make are not that huge compared to if they feel happy at work they will do it.
Well, I think it's true. It's like the best developers are always like going to be most productive when they just feel like comfortable and happy and they get to like do the things they want to do.